Hello Professor, my name is Ryan Verghese, and in this video I'm going to talk about my code and how it works. So in the homework problem, we are to fill in an m times n rectangle with the numbers 1 to mn in a random order. And our goal is to minimize the cost of the arrangement, where the cost is defined as the sum of the absolute differences between the adjacent numbers in both the rows and columns. It's a bit of a difficult problem, but I think the good solution for this is a genetic algorithm. So in this folder, I have four main Java files, and I'm going to explain what are these Java files is about. So the first one is the individual class, and they have several key methods, which is the individual method, which randomly fills the rectangle with numbers ensuring a random initial state. Then we have the getFitness method, which calculates the cost of the arrangement, iterating through the rectangle and summing the absolute differences between the adjacent numbers. Then we have the getGene and setGene and size methods, which provides the basic utility to interact with the individual genes, where then each gene corresponds to a number in the rectangle. These methods are very crucial for implementing the crossover and the mutation operations. The next one class is the population class, and this has a method to initialize itself, creating a population of individuals with random genes. It also has methods to retrieve and set individuals in the population, and crucially, a method to find the fittest individual, basically the one with the lowest cost. The next one is the genetic algorithm class, and this is basically the heart of the program. So the methods we have in this is the evolve population, which applies crossover, mutation, and selection to create a new generation of solution. The crossover combines the genes of two parents to create offspring, and the mutation introduces random changes by diversity, and the selection picks individuals from crossover based on their fitness. The crossover, mutate, and the tournament selection methods are helper functions that perform the specific operation. They are vital for ensuring that genetic diversity and gradual improvement of our solutions over time. And then we have our main function class, which basically where everything comes together. Here we take an input from the user for the dimensions of the triangle, initialize our population, and run the genetic algorithm for a set number of generations. Then after evolving our population, we retrieve the fittest individual and output its arrangement and cost to separate test files. This is not just a solution, it's a tangible result of our genetic algorithm at work. So in here, I'm going to show you how to run the code. So I am using VS Code. So I have all my files here. So I'm going to terminal, new terminal. And if you don't have the classes here, you just put the command java c star.java, and this will make it classes for each of the Java file. Then after that, to run the code, you do java main, and the first input we have is the 4 by 5. Here we see the initial solution is 316 with and the matrix from 1 to 20 in random order. And the finished is the total cost, which is 52, and the new solution. With this, the new solution and the cost are then put into a text file. Right here we have the solution matrix for the 4 by 5, and then we have the solution cost for this. Now for the second input, java